Dear all, Assalamu alaikum. I hope you're all well. Uh, Today we will again discuss about this EI technique. So today we will try. In fact, we have to finish this whole technique in the today's lecture because we can't give more time to this technique, right? So there are so many things that I will try to cover up by myself, but the other things I will give, I mean, if they are the similar things, I will try those to do a little bit of that, and then I will give some part of for you for the practice. Because if the similar things they are repeating again and again, so it would be better to give it to you to try on. So let's start the today's lecture. On the screen, you can see that what is the selected ion plot. So this is the as I have already told you in the last lecture that sometime we are interesting to take the graph of the particular components, right? So how to do that? So you can see that in this graph, we have tried multiple components. So this is, you can see that there's a mixture, right? And this mixture is consisting of so many of the compounds, right? If we are, these are the molecular ion peaks at the very right. So as you can see, you know that always it is in EI, the highest mass peak is always supposed to be the molecular ion peak. So if we assume that this mixture consists of these so many components, and we have plotted the graph of these components, so you can see that this is one component, another, third, fourth, fifth, sixth, and these are the intensities of those peaks, right? Some of the component they are coming at the highest intensity, some at the low, some have low intensity. Uh, at the x-axis, you can see that there's we are observing two things. The analysis time is also increasing from the left to right, as well as the temperature is gradually increasing. So when we are gradually increasing the temperature with the passage of time, the analysis time is also increasing. So with the gradual rise in temperature, you can see that some of the component they are appearing very early, right? They are giving the molecular ion peak very early, like this component A, B, C, they are giving the molecular ion peak very early. But the other component at the low temperature, the temperature has not been given, but you can see that at the analysis time of 2 minutes, this is in minutes, at 2 minutes, this first few peaks, they are giving the molecular ion peaks. You can see here 149, 167, 143. But what about this one? As we are moving ahead, rising the temperature, now this component start giving the molecular ion peak. I mean the one two with the M by Z of 224, 280, they are giving peak. But still there are other peaks which are still, you're gonna see that they're not giving anything. And even when the temperature is rising and the analysis time reached to what is that, like the 5 or 6? Yeah. So this when the analysis time reach up to the 6 minute or 7 minutes, 5 to 6 minutes, these components they are giving the molecular ion peak at the 280, 305, etc., etc. So what does it mean? It means that in a mixture we have different compounds that gives the molecular ion peak at a different temperature. At a very low temperature, some of the component they will not, I mean, they would need a very high temperature to, to go to the excited state, and then, to ionize and reach this excited state, and then thereafter the following and their dissociation and fragmentation. But some component need a very little energy, and then they are excited, and they are when they reach the excited state, of course, that will be followed by their dissociation and following fragmentation. But for the some component, the temperature would be high. So that's why they would give the molecular ion peak at a very high temperature. Here they have given the 29 scans altogether. Up till here, they have given 29 scans. So as you know that the scanning could only improve the resolutions and the so other than this, there is no purpose of scanning. Scanning means that some of the things they will be appearing at a very high scanning. Increase the scanning is actually enhancing the signal to noise ratio, right? So you can see here that this on the spectra, if you put the cursor on any of these peak, you will get spectra for that. For instance, if I'm putting spectra on this, that will give me 149 following by the fragment peaks over here. If I'm putting the cursor over here, it will give me the molecular ion peak at 224 following by the fragment peaks. So you can see spectra for each one of these. Um, let's move on. You can see here what this is showing. The mass spectra acquired for probe temperature up to 20 to 200 degrees centigrade. Now, when you are, as you can see that at this time, again, the intensity, and on the right side, you can see the time, the analysis time is moving on, increasing up to the 20, at below 1 minute we are maintaining a temperature of like 20 degrees centigrade, but as we are moving with the time, right, the temperature is also gradually rising up to, so you can see that when we started with the 20 temperature, the peak is rising. It has started rising, right? The peak is rising, and we can see that it's not straight one, right? So the peak has started rising from the 20 degree centigrade, and it has stopped rising after 200, means at 200 degree centigrade. So it means that the overall peak for this compound, they are coming from the 20 degree centigrade up to 200 degree centigrade. When we and then thereafter this temperature at the higher temperature, the peak have stopped, and now this is a straight line. So it means that the probe temperature that is required, because we have to consider the last component also. For instance, the first component is giving the peak at 20 degrees centigrade, but we have to check the last component, even if it is giving them, because we can rise the temperature up to 350, all the component they will be appeared at this particular temperature, 350. But once we have reached up to the 200 degrees centigrade, you can see that all the component now they have finished and they have given the molecular ion peak. And this range is from the 20 from the limit where the analysis time reached to the below 1 minute till the 7 minutes. So up till 7 minutes, the temperature has risen from 20 to 200 degrees centigrade, and at this temperature would be sufficient for all even the last component to give the peak, right? So this means that the overall probe temperature would be from 20 to 200 degrees centigrade, because this temperature is the total range that is required for all the component to give their required peaks. So you can see if you are putting the spectra cursor on each of these peaks, you can see that you will get the spectra. But what about, you can see that at all temperature, at a very low temperature, it has given a peak only of 278, but as we are rising the temperature, it can give the m by z of even 305, right? So it means that this 305 was not appearing at a very low temperature. As we have raised the temperature, it start appearing, right? So it means that some of the component may have a very high, require a very high temperature for the excitation, and that's why they will appear later on as like this one. So you can't say that by giving a low temperature and you would expect that that will, whatever the peak they gave, that will be counted as a molecular ion peak. No, this is not the case. Sometime it would have sometimes it's possible that as we are rising the temperature, later the molecular ion peak appear. So that last peak would be our molecular ion peak, right? So you can see from here that all temperature, low temperature, and a very high temperature. So this is the last stage where all the peaks appeared. Even you can rise the temperature even more. Let me explain in the next video.